Okay, good evening, gentlemen. So I'm recording. So today is the 12th of January. Okay, 12th of January. We are doing the still on the topic 5, finishing already. We'll finish up this topic so that your topic 5. Okay, so we'll start. So your quiz will be on the, what day did I tell you? 26, right? 26th of January, Tuesday, during lecture hour. So next week is your practical test. So may I remind you that for the PE1 group, please come at 6 p.m. For your practical test. The test will be 40 minutes. Okay, 40 minutes. So, and then the Mr. Chan's group P2, you all come at 7 p.m. Okay, can? 7, can? So last week we talked about the reliability thing, right? This one will be tested for your quiz, so please take note. Okay, this one will be quiz in your quiz. Yeah, no. This one I shared with you last week. These are the old slides we have seen last week. So I was just quickly refreshing this thing. Okay, and also my last week lecture also recorded, uploaded to the cloud already. So you all should be able to view the open quiz close book. Okay. Right, can. So then we'll talk about this one. Last week also I show you, explain about this thing called the mean time between failure, right? MTBF. Those yellow highlighted one is important. You must know. Okay, this one you must know. Okay. Last year then I give you some sample, right? Some example. You can attempt the tutorial question also. Right. Then I explain further on to talk about this reliability versus the failure. R over T. RT is reliability. FT is failure. Okay. So the sum of these two must be always equals to 1. Okay, just like your percentage is always 100 upon 100%, right? Okay, same thing. Then I given you an example about the machine, right? Some equipment, okay, trying to calculate some of the probability in terms of the reliability. For example, over this case is 60.65% and so on. Last one we did last week, right? Then I went on to, remember last week I showed you one video about the IKEA, the chair, that one. Okay, that one they do the cyclic test, right? So sometimes your test may not be in terms of the time. It could be in terms of cycle. Okay, so how much compression you put to the chair. Okay, so we call these cycles. Instead of time based, it is cycle based. Alright. So in this case, we talk about MC, MCBF. Yep. Okay, try to settle down. Yes, topic 5 only. Filters and this one. Okay, so you must study 5 questions. I checked already. Short question. There are calculation one a bit longer, but there are 2 small theory questions. Short one. Okay. Can so and then look at the lecture examples and then go through your tutorial question. Should be fine. Should be able to do it. Okay. So this one mean cycle between failure. Yep. So I've also given you an example, right? This one here. You can look at this set of notes here. Okay, where we look at some machine. Some machine units. Okay, then you have an example here. So if you say that this machine has a certain lifespan, what is the probability of failure? Or probability of operation without failure? So we are looking at the reliability then. Is that okay? So we have this, right? The lambda 1 over this MCBF. So you calculate then you just substitute into the formula here to get the reliability. Yeah. So this one probability of the reliability very low, 34%. Okay, very, very low. This one, this example. Okay, can? Can, this one. Just now that one. Just basically applying the formula. Now the next two things are quite important. This one, the laws of reliability. This one will be tested in your quiz. You must study. Must study. Okay. Now, in this thing, we also, this reliability thing also have this thing called system in series or in parallel. Very interesting. Okay. Last week I shared with you, right? Aeroplane, right? Airbus. Airbus got built-in reliability, redundancy. Okay. So that means that the system, as I said, the aeroplane can fly with one jet and one of the turbine running, one shutdown, still can run. Because they built in with reliability, because they have this thing in parallel. Okay, which I'll show you. Okay, everything parallel means you got redundancy, right? Redundancy means you got like backup. Okay, I have one of thing, but I got one parallel over it. I got another one parallel. Okay, for example, okay, this one. Let's take a look at this example. Okay, now R stands for reliability. The lambda is the failure, right? Failure rate. This one. So if you have a system that is in series like this, obviously you can know that there's a problem. If because any one along the chain breaks, the system will fail. Right? It's common sense. Agree? The whole chain, right? If any of these things break, the thing fail. Okay, so you can see that later we can show you. I'll show you an example. So you have all the different components. If you like, I can have many components in a car. Let's say. Okay, so if the car engine with the transmission gear, one of the transmission gear spoil, break down, right? Your car will have malfunction problem. Okay, and so on. So in a case of a series configuration like this, you basically multiply the reliability. Okay, so let's say if this one is 0.86, this one is 0.99, let's say for example, and so on and so forth. Later you will multiply them together. So the reliability actually drops quite drastically. Okay, same for the failure rate. For failure rate in series, you plus them. Okay, so let me give you an example here. Now I have an example here. Okay, a real number example here. Okay, so if you look at this system here, you are asked to calculate the total system reliability given this parameter. So maybe the sensor, you have the signal conditioning, then you have the component ADC here. Okay, so this one, maybe the first sensor is 0.95, right? 0.95 over here. Then the signal conditioning one only 0.9. And then the R3 here, the reliability is 0.8 for this component. So because they are in series, right, you multiply them. You realize that the more you multiply, the worse the thing becomes. The longer the chain, the reliability becomes worse, right? Makes sense, right? Because you are more dependent on each one of them. So if any one of them fail, your thing will fail. The whole system will collapse. Right? You see? R1 times R2 times R3. The more you have, you realize this number will go down, become worse. Oh, makes sense, right? Series, one break, all die, all break. Okay, so series is not reliable in many cases. Okay, so this one you can take a look. So likely in the quiz, right, we will give you some calculation based on this kind of thing. Okay, then the other one is parallel. So parallel one is better. Let's take a look. If you have a parallel system, we only give you up to maximum of how many? Let me try and recall. I think up to 2 or 3 only. 3 is the max I can give you. So that means that there's a fixed formula you must remember. Fixed formula. Let's say, for example, you have 2 components in parallel, right? This is the formula that you will apply to get the RS is the total system reliability. RS is the total system reliability combined, the whole thing. Okay, so if you have these 2 components like this, R1 and R2, you will do this. RS equals to R1 plus R2 minus R1 bracket R2. So this is means multiply. Okay, this part is multiply, this one is this plus this. Then you minus the multiplication of these two. Okay, so that's the reliability for a parallel system. Okay, let me give you an example over here. Okay, this is the one that we will test you maximum at 3. Okay, this formula is for a maximum of 3 components. Three components, 3 only. We will not test you more than beyond 3, because beyond 3 you must use the mathematical binomial theorem, but not tested for your maximum I can give you is 3. So for a case of a 3 components in parallel, let's say for example I have 3 thermocouples in parallel, let's say. Okay, remember I told you the aircraft thing, redundancy, you put in extra. So in case one fail, you still got the other backup. So something like this. So let's say I got 3 thermocouple in parallel. Okay, as an example, I will calculate the reliability. You notice that for 3 components, the reliability not too bad, right? Quite good, right, actually. You calculate, if you calculate, you plug in that. The red color one is a formula, fixed one. This formula is fixed. Not given, that's the thing. But the maximum I can test you is 3 only, as I promised. I cannot give you more than 3. Huh? Try to give 2 lah, but okay, but I don't rule out. I don't rule out that I cannot test you. I must go and refer to the question again. But 2 usually very common. 3 question is also not too difficult lah. Yeah, please sign your attendance, guys. Okay, 3 is the maximum I will test you at max. Okay, so 3 component case you will do this lah. Okay, to find the system reliability, RS equals to this one plus this one plus this one. Then minus away this different the combination. Then plus the multiplication of these 3. Can not too bad lah. 3 can still doable. No lah, not okay lah. Can. 3 component. Maybe, I can't remember it. I will give you 2 or 3. 2 lah, 2, let me see. But anyway, I just put it in. Okay, I just put it in for your info. This one, you must take a look, take note lah. Okay, but really 3 is the maximum I will test you at 3. Up to 3 only, max. Okay, 3. Common test? Quiz you mean? No more common test. Common test over it. Quiz. Yeah. Final exam no more. Okay, I just tell you one thing. This one, right, I only test you during the quiz. Common test, no. Final exam no more. This one will not be tested. Okay?
Until now, quiz you haven't give clue.
Then I told you already, the topic, this topic 5, what? The one I cover the filter one. All about filter. And everything about the reliability one. That's all. You study those things enough already. Yeah, filter question will come out, and also the reliability one. Theory maybe 1 or 2, but very low marks only. Theory like maybe I ask you what is
So SRN come out. SRN.
What is SRN?
The SRN. SNR, sorry. Noise.
Oh, the noise no need to study that one. Leave out that one. Don't leave out. For example, I ask you a question like maybe, can you tell me what is accuracy? Short theory question, maybe 2 or 3 marks kind of thing. Okay, what is accuracy? No MCQ one. No, we don't practice MCQ one. Okay, what is precision? Maybe I ask you a question. Okay, you all should be able to write something for me. Okay, you want theory? I ask you like that. What is precision? You may draw that bullseye diagram and then you start explaining, it's fine. The bullseye chart, that one, the dartboard, that one, you can explain based on that. Can also. What is active transducer? Maybe I ask you. Short question, very short one, very, very short one. 2-3 mark kind of question. But rather you focus on the calculation. That's very important. This one, let's say for example, how to calculate this one. If I give you a figure like this, can you calculate? Question come out based on this kind of thing. This one, okay. I can ask you this one, maybe. I'll ask you one question to test you. Okay, is it okay? So I just try to move around so that you all can capture the video, can capture the screen. Okay, this one, for example, maybe something like this.
Sir, got partial quiz paper.
Huh?
Partial quiz.
Partial quiz.
Let us do then we practice.
No lah, actually worse don't ask for that because you just do my this one is very good enough trust me. Okay, don't ask for the one. If you partial quiz, I give you partial quiz, means my question I will change so better don't okay. I suggest you just study this one, this kind of example. Look at my tutorial question, it's good enough trust me, take my word. Trust me. Really, later you see later you see, you go and ask the past year those students. And then look at this, some of this my question, this kind of thing. Good enough, really. Okay, sometimes the more you ask things become worse because the question keep changing worse because you know why not? I release more question to you means I must update my question bank you go and think. Okay, come, let's move on Is it okay? So this one, go and study Study good enough good enough. Okay, so study this one, the series and the parallel. Okay, so I finish up this topic So I pause first. I'm going to switch to the next thing.